maybe check the Twitter. Let's check. Okay, looking good. I think on this side. All right.
What's the link I should use?
Decontrol van. Oh, not that one. It's the other decontrol. That's me. Yeah. This one's van. Yeah. Where's Christian? Christian, you got? Can you retweet from EthVan? Oh, what am I even asking? Why do I even ask? Yeah, if you can hop over to that other side, and then Kai, just watch this. I think sitting.
Actual Fireside vibe.
Yeah. Okay, maybe just pull it in a little bit. Just come in a little bit. Yeah, just so you see.
Should we look like
I think it's
at each other?
all right.
Testing.
Okay, everyone. All right. Oh. Okay. All right, everybody. Thank you for coming here tonight. Yeah, again, we've got once again another Thursday evening here of Decontrol at EthVan here at Decontrol. So thanks again. It's been 2 years now. A few of you here were for the 2-year anniversary, so appreciate everybody coming here. Yeah, so we've got a kind of a special one here tonight. But yeah, so we've got coming up here for announcements and whatnot. We've got the Nouns Run. So if anybody wants to go running on Saturday noon, meet at the Cole Harbor or at the Cactus Club in Cole Harbor. Yeah, quick 5K run. Get ready for that. Next Wednesday, I believe we have NFT and coffee from 4 to 6. So if you're looking for that, looking to talk about NFTs and things, come on down for that. And then we've also got the ZK Research Group the following Wednesday. We'll have that. That's at 6:30 till 8. Okay, cool. And okay. Here, take.
Oh, so the Virgo Crypto Summit is this Saturday. I think it's from 10 a.m. to 5 p.m. at UBC Robson Square downtown.
Perfect. Okay, and I think we've posted some links in EthVan server. We'll maybe retweet from.
It's on Twitter. It's on Discord. It's on Telegram.
Perfect. It's everywhere. So yeah, if you haven't already, please join our Discords. There's both there's the high one up there. If you scan that QR code, that takes you to the EthVan stuff. So that's everything related to EthVan. You can follow us on all the socials. Please do that. Like and subscribe to all the things. And then the other one is for Decontrol. Yeah, just another bit of coverage for that as well. So that'll take you to decontrol.wtf. So yeah, all right, we're gonna dive into this. Yeah, if anybody has questions throughout all this, please make sure you put your hand up, get yourself a microphone. We are live streaming, so we've got a bunch of people at home that want to hear all this stuff too, so they want to hear your questions and all that. But we'll start off with just like a few little things to kick us off, and then we'll open it up to a Q&A session. There's also a PO app. So on that little black poster on the side wall there, and it'll say there's a little card-looking thing. It says POAP on it. Go put your phone there. See, look, he's pointing at it right now. Go put your phone up against it. It'll give you a link. You open that up, put in your ENS or your public address, and you can mint a POAP of this magical moment that we're having here tonight. A beautiful memory. So anyways, let's dive into it. Tim, thanks for joining us tonight here. And yeah, if you don't mind, just maybe start us out with letting us know what you do at the EF and what parts of Denkun you were involved in.
Big question. Yeah, thanks for having me. My name is Tim Beiko. I work at the Ethereum Foundation. The main thing I do there is run what we call the All-Core Devs calls, which are these calls that we host every 2 weeks, where different protocol developers get together to chat about potential changes to Ethereum and eventually agree to them and then work on implementing them. So over the past, I think it's been 2 years now, we've been working on this upgrade called Denkun, which we can talk about at length tonight. And yeah, my role in that is basically I help like run the meetings and just facilitate the process around like us getting from there's a bunch of things we could do on Ethereum to like here's things we're actually gonna do and ship.
Sweet, sweet. Okay, so Denkun, where does this name derive from, and what's the meaning behind it?
So Ethereum today has a proof of stake chain that manages all the consensus, and it has an execution chain that actually runs all the transactions. Those things started as separate like software components. The proof of stake people like to use star names for their upgrades, and they just go alphabetically. So it's like Altair, Bellatrix, Capella. On the execution side, we like to use the name of DevCon cities. Now we've merged. So we sort of merged the names too. So Denkun is the mix of Deneb, which is a star, and then Cancun, which is where they had the third DevCon.
Cool, very cool. So yeah, and if anybody was curious about that, it kind of gives you a little more insight into the magic of Ethereum and the naming. All right, well, maybe let's start kind of getting into the high level of it, like around what are the main features of Denkun and I guess like EIP 4844, or I guess like proto-dank shorting.
Yeah, okay, so that's like by far the main one. There's a bunch of other things, but 90% of the focus is on this one. Yeah. So I'll give like a 10-second overview and then like a 2-minute version, and then we can do questions if the 2-minute version wasn't clear. But 10-second overview is this is just going to make transaction costs on rollup cheaper because it introduces temporary data storage that rollups can use. 2-minute version now. So Ethereum is this layer 1 blockchain, which is limited in throughput. So there's only so many transactions we can do every block. Because of that, when there's more people that want to make transactions than block space, the price to do transactions goes up, and this prices out a bunch of people. The other thing you can do on Ethereum instead of just running transactions is you can store data there, and storing data is actually cheaper than running computation. So rollups are like this really interesting idea where what they do is instead of running every single transaction on Ethereum, they run the transaction somewhere else, usually on like what they call the L2 chain. And then they post back the compressed data of those transactions or ZK proofs of those transactions in the case of ZK rollups back to the Ethereum layer 1 chain. And they sort of exploit this like pricing asymmetry between the cost of running transactions on L1 and the cost of storing data. And this is basically why storing data, making transactions on L2 is cheaper than on L1 because you only have to pay L1 for like the cost of storing the data, and then the cost of computation is actually pretty trivial. And this is all like a high-level simplification. I know there's like a ZK guy in the audience, so like I'm gonna butcher this, but like it's like explain like I'm 5 version. So like rollups are cheaper today because of that. But today there's only one way to store data on Ethereum, which is you store it like forever. So when rollup posts data to transaction, they basically pay a storage fee that effectively pays to store it forever on the network. In practice, the rollups don't actually need the data there forever. If you look at, say, optimistic rollups, they have these things called like these challenge windows where if you withdraw funds from an optimistic rollup, they basically wait 7 days. And if no one has like contested your withdrawal in 7 days, you're good to go. And the idea there is like, if all the data is on L1, within those 7 days, somebody could like look at the data and see if you did like a fraudulent withdrawal and then call you out on it. And they have this whole mechanism around how you dispute that. And then ZK rollups need even less time to like have like people verify the data on L1. So right now, rollups are in this spot where like they're paying for infinite duration storage, but they only need the data for about a week. So what we're doing in this upgrade is we're introducing basically temporary data storage on Ethereum. So the data that we're introducing, we call them blobs. It only sticks around on the network for about 3 weeks, and after that, it gets pruned by the network. You can always verify that, like, if you have a piece of data, you can always verify a proof on it. So, like, if you got it from somewhere else and you want to verify on chain that it's actually correct, you can do that. But you won't be able to retrieve it from the network. And so, basically, the idea is that if you're only paying to store the data for 3 weeks, then it's cheaper than paying to store it forever. And so, rollups can pass on those transaction cost savings to users. And today, like, a rollup transaction is about 90% data costs. So, like, if by whichever amount we reduce that is like effectively like all goes through the users. So I'll pause here. That's like a 2-minute version. Yeah.
Great. That was a great overview on all of this. So you mentioned blobs. Maybe let's talk a little bit about what blobs are, what that kind of looks like. what the heck is a blob?
Yeah. So what's a blob? So again, I'll start with like what we have today and then explain how blobs are different. So today, when you make a transaction on Ethereum, you can include some arbitrary data. We call that call data. And say when you see like an NFT that gets minted and like stored on chain, what they do is they include a bunch of extra data there, and that's like the NFT, and that's included as part of the transaction. Rollups do the same thing today, so they like batch up transactions that happen on their L2, compress that data, do a ZK proof for it, and then include this in the call data of a transaction. And then when you query that transaction on chain, you can just get that data and again, just like do your verifications. So blobs are effectively the same thing, but instead of like you have a new transaction type, which instead of having call data where you include the extra data, you have what we literally call a blob. And then you just put the data there. And by putting the data there, what happens is the data is actually never stored on the execution chain. It's stored on the beacon chain, and then it gets proven every 3 weeks. And then on the execution chain, we have this this proof system where you can always verify data. So it's effectively just a new transaction type where the data is stored in like a different place, and then it's just managed in a different way to get pruned after 3 weeks.
Okay, and so is this like the transaction 3 type? Is that what you're referring to, or type 3, or is that different?
I think it's type 3, but I'm pretty sure it's type 3.
Okay, sweet. All right, and so that's why these are different than the other ones because of these mechanisms.
Yeah, every time there's like a change to like a transaction. Like for example, 1559 has like transactions with base fee. When we introduce that, we need like a new transaction type because you want the old transactions to be valid. We have a new transaction type. Pretty sure it's number 3.
Yeah, cool. And then they're cheaper than call data because how does it, because it's not stored everywhere, or how does that?
Correct. So actually, okay, now we're really getting into the weeds. So in practice, there's a different fee market for blob gas, so basically, today when you have your call data transaction, you're competing with everybody who just wants to make like an actual computation transaction on chain, and you're like having to bid against them for gas. So you're raising the price of both like the normal users who just want to like do stuff on L1, and then of the L2s who have to compete with way more people. So what we do for blobs is we have a separate, call it a fee market, like a separate auction where the gas price of blobs is actually like in a different pricing auction than the gas price for computations on L1. And the idea is that because this is like blobs are not useful to users doing computations on L1, they're not like competing in that auction. And then for L2s, effectively, they're just competing, or whoever else wants to store. But blobs is just like competing amongst themselves. So there's like less demand there, and then the price for those transactions is lower.
Okay. So do you see like, basically they could be lower or higher, however, but like, do you see like kind of a market for this sort of thing starting to happen, or is it just like?
Yeah. So it's effectively like a second fee market. So we're going to have, and at the end of the day in the transaction, it all gets like, abstracted into one number, the same way you have like gas and gas price and all of that. You end up with like a fee at the end. But you can think of this as like there's like an execution transaction pool fee market. There's like a blob transaction pool fee market, and those two things are like somewhat independent.
Okay, cool. And how big are blobs? Is there a size of them?
Yeah, they're I think 128K per blob, and then blobs we can have 3 blobs. You're going to have 3 blobs on average per block maximum, and then up to 6. So it's kind of like the gas limit. It has like a elasticity. So the target is 3, the top is 6, and then each blob is 128K. And you have to like use the full blob. So I know like there's projects now that are working on like blob sharing, basically. Like if your rollup doesn't need 128K, maybe you can like pool your blobs. But when you send a transaction, you pay for the full 128K.
Okay, gotcha. And that was kind of my next part here was like with like who will be using blobs? You see this as like mainly L2s, or is there like other?
Oh yeah, basically like L2 sequencers. Like if you're a normal Ethereum user, like I don't know if I'll ever send a blob transaction, right? Like maybe I'll try it out, but like there's no normal user flow where like this is going to be used.
Yeah. So yeah, as a normal user, but it would either be L2s. Do you see like other projects or other things like an app or a DApp or something trying to use this?
Anyone that wants to use like Ethereum for data availability, basically. Like I'm sure a bunch of these restaking projects will use it. I'm sure like but like think of it as like corporate users, almost like B2B, right? Like so the like users of blobs are like usually technically sophisticated. They're like compressing a bunch of data in like the smallest possible form. So like yeah, L2 sequencers, potentially some like restaking infrastructure. I don't know if there was like some. I was gonna say an NFT project, but then it's kind of weird because you'd want the NFT project data to probably be on stored forever, not just for like 3 weeks. But yeah, like high data throughput users.
Question.
Go ahead.
Yeah. I know we always think things are gonna happen or behave in a certain way, and then people put fart sounds on Bitcoin mainnet. You know, is there some type of way of like how users use blobs, or could it be that someone just decides to spam blobs with?
Yeah,
like,
I mean, you can pay gas
whatever.
and spam blobs, right? Like from the network's perspective, blobs are just 128 kilobyte of random data that you can get approved for. If you want to like fill it up with zeros and like pay the gas price to take up the block space and do that, yeah, you can. And it's just in practice. Like for example, in practice, you know, like MetaMask is not gonna like let you sign a blob transaction by default. The same way, like for example, when we launched 1559, they like converted the default user transactions to 1559 because the pricing is just like better that way. Like I don't anticipate consumer wallets doing that, but like yeah, anyone can, like it's a permissionless fee market. Anyone can go and like yeah make blob transactions.
So then with these blobs, like how does this get propagated to the network? Like who's all involved in this? Like this all goes through the whole PBS thing, or how does this? Where does that? Because this is kind of like a new portion of the whole system.
Okay, yeah. Now we're getting really deep. So blob transactions get propagated through like the mempool. There's actually some different rules around mempool because the blob transactions are big. We don't just like naively request all of them. You usually just like request a hash, and if you're missing it locally, you request the whole thing. So it's kind of this weird thing that's being. We do this with like blocks right now, and like other larger chunks of data versus transactions are usually small and you just like request the whole thing. So they're kind of, I don't know, like a peer-to-peer level somewhere, treated somewhere between like a block and a transaction to save on bandwidth. But then, you know, once it makes it in like your local mempool, like any validator can just, from a validator's perspective, it's just a transaction with like a gas price and a gas used, and like, you know, they know they'll make this much. And then if a validator's, you know, using something like an external builder, the builder can obviously just, you know, include blob transactions as well. But you can see like it's kind of trivial to see like, is your blob transaction paying you more than like a random L1 transaction? And then if it doesn't, then you probably shouldn't include it. But then the blob transaction is only competing with like other blob transactions to pay for like that blob storage cost.
Got it. And in a case like where we have an L2 that's like trying to, you know, post a you know, the data of the blob, like they'll still pay a higher fee and make it worth, you know, it worthwhile to get in. So.
And then the difference though is like that, you know, like that fee is amortized across all the users, right? And then they can put like more data in that transaction. So yeah.
Yeah, cool. So as we start spreading this across here and we kind of get into like the, you know, back to the thing that everybody's excited about here with like lower fees. So how, like, what are we kind of expecting right now for like fees on, I guess, like L2s and whatnot? And then like, would there be any kind of, do you envision a reduction on mainnet as well?
This is like as hard as like a price prediction question. So and I guess it depends on a bunch of things. So like my short answer is like I don't know. Like there'll be some price reduction on L2, probably a trivial price reduction on L1. But the thing is, demand on L1 is so volatile that like if there's like a 10% price reduction, like prices move more than 10% like from an hour to another. But like on L2, like yeah, like you'll almost certainly see lower fees because you just have the separate market which provides more data, which is priced cheaper, and then L2s can just, you know, compress their transactions and put them there instead. And I know some L2s are like keeping the option of having, you know, call data as a fallback if like at the start, I don't know, everybody wants to try out blobs and the price goes up or something. So like it's not a guarantee that it'll be cheaper, but like when you look at it, it's just like this whole market with more space. Like there's just like way more supply. So like maybe if the demand goes up because of it, then like the price will be the same as it is today, but then you're serving more users at that price. So it's just really hard. But basically think of it as like we're creating supply for data, which like in aggregate should lower the price given a fixed demand level. But demand is super, super volatile. So like, you know, if I say this and I don't know, in a week there's like twice as many users on Ethereum, then like the price of transacting will still go up. Yeah.
Yeah, that's fair. But yeah, at least like the throughput, like it's kind of giving higher throughput essentially.
Yeah,
throughout.
correct. So like, yeah, at the same price point, you're serving more people, basically.
I just had a question. So if one was validating, and they hit a block, you have consensus income and then execution income. Are you now going to see a third category of?
It's not a third. It's part of your execution layer rewards.
Okay, so it won't be marked differently.
No, I mean,
okay.
I don't know. Maybe Etherscan or Beacon Chain will like break it down for you, but it's like
Okay.
you'll get this on the execution layer. It's not going to be accruing to your validator balance.
I understand. Okay, thanks.
Cool. And I guess like that kind of segues into the next one here. Is there anything like stakers or validators that they need to do before Denkun, or things that they should be expecting or kind of thinking about?
Yeah. So like one, upgrade your nodes. We have a blog post at blog.ethereum.org with all the node versions. Do that before next Wednesday. Two, in terms of just like extra like storage. So the blobs do cause extra like disk storage. I think it's somewhere between 50 and 150 gigs, but it's capped at that because it's like the max amount of blobs you can have over like 3 weeks. And then, when you start adding the new ones, you delete the old ones. So it's different clients have like different numbers on that, but like somewhere between like 50 to 150 gigs is what I saw. So that's like the main thing that you should just be aware of as a validator. Yeah.
And how long are blobs before they're deleted or before they're wiped, or how long? What is that time period?
4,096 epochs, which I think is about 3 weeks, give or take.
Okay, 4,096 epochs. Okay, very cool. And as far as a user, okay, go ahead. User, take the mic.
Okay, yeah, this is sort of the first instance of like localized fee markets on Ethereum. Could there be more in the future?
Yeah, some people want to see more, but like there's a cost. So the trade-off for like more fee markets is just like the computational complexity of like resolving all of them versus like how different those resources are priced. So like some researchers are like, we should have 7 fee markets, but then it's like when you're sorting your mempool, it becomes like an extremely computationally intensive problem. So I don't know, maybe we'll see more. Every time researchers say like we're gonna do multi-dimensional fee markets, I tell them like you should just approach it like, say we're just gonna do one more and one more and one more, and maybe we'll get to like 5 that way. But like, there's just like a computational cost. So, yeah.
What might be the next step? Like, what do they propose next fee market is?
So like, for example, people would like to price call data separately from like executions. You could imagine doing that, but the counter argument to that is like it's just easier to raise the gas price on call data and push people to blobs. So that's like the poor man's solution. The other thing is like state growth. Like maybe we should have like a separate fee market for like things that involve the state and whatnot. And like again, it's just not clear if the complexity of doing that is worth like whatever incremental gain you get in like pricing optimization.
Okay, and then as a user, anything we need to do as just a regular Ethereum user? Everything should be just kind of like the merge almost.
Yeah, everything should happen behind the scenes as a user. And then we can talk for devs because there's a bunch of other EIPs in the fork that like can affect devs. But like if you're just a vanilla Ethereum user sending transactions, nothing will change. I mean, your L2 transactions will probably get cheaper, but like nothing will change.
Can you talk about full dank sharding and like how long after you expect it to be, and just the details surrounding like
yes.
upgrades?
I won't tell you how long because I have no idea, but I can tell you like what it looks like. So okay, so if we sort of go back a bit, we said, like what we have today is like Ethereum has to store all the data forever on all the nodes. This is expensive. So now we're shipping this thing, which is like we store all the data for some period of time on all the nodes. The idea with full dank sharding is instead of storing data for a short amount of time on all the nodes, is you store it on only a subset of the nodes, and then you do some probabilistic data querying across the network so that you have a high guarantee that like the data is available in many redundant places on the network. So that's the difference between proto-dank sharding, which we have now, which actually is not like sharding in a like computer science term. We're just on the way there. But then full dank sharding is actually sharding where it's like you're saying, okay, the data is somewhere on the network. I might not have a copy locally, but I've done enough queries and received enough confirmations from the network that like the odds that some of the data would be missing are like the odds of a hash collision or something like that. So that is just complicated to like set up that whole querying infrastructure. People are working on it. Like it'll take years. It probably not be like 1 year, probably not 5. Yeah.
Would you be able to explain the differences between something like Celestia data availability sampling and then the version that I'm assuming you're doing here?
Short answer, no. Long answer. But I mean, maybe the biggest like high level difference is just like which validator set is backing like your data availability, right? Like, so assuming Celestia did the exact same thing at Ethereum, which is not true, and I'm not sure where the details differ. It's just, you're relying on Celestia's validator sets to secure your data versus Ethereum's.
Oh, I just meant if you knew like any of the technical differences.
No.
Okay.
I have a question from Restream.
Oh, nice. Thank you.
Who will save the blob data long term, and how would an L2 disaster recovery or disaster recovery?
Yeah. I mean, whoever wants to save the blobs long term, right? Like, so I think the way, like the sort of vision for Ethereum is a bit less like a database and a bit more like a bulletin board, where if you think of like the security budget of Ethereum, like we have all these validators giving us like billions of security. We can either like spread that security budget over like the entire history very thinly, or we can like focus it on like what's happening right now. And the argument to focus it on what's happening right now is like stuff that's happened in the past is usually cheap to verify and also like less likely to change. So imagine, you send some funds to like Coinbase and you like sell them to buy a car or something. I don't know, you can do that process in like 3-4 days. Coinbase has to be pretty certain that like your funds are actually going to be there. They got it. You're not going to revert the chain past that. And so, and whereas like if you send a transaction to Coinbase, like right now, I don't know what their confirmation period is, but like in those first couple blocks, there's like a higher degree of contention on what the tip of the chain is. And so you kind of want to focus all the economic security around there, right? And you don't have to be as like 30 confirmations or something, but you can be like pretty biased and saying like, Ethereum's validator set is going to secure like this like 3 weeks of archive and like put all its weight behind that. And after that, you're kind of on your own. Etherscan might have a copy, Internet Archive might have a copy. If I was Arbitrum or zkSync or Optimism, I would for sure keep a copy of my blobs and, maybe pay the DAO to like, or get the DAO to pay like redundant copies. But then if you have a blob, you take it from like the zkSync archive or whatever, you can go back to L1 and verify like, okay, was this like a valid blob? So L1 should give you like the really strong like guarantees about what's happening now. But then, long-term storage, there's better and cheaper places than Ethereum to do that. And people have like a high incentive to do it. Yeah.
Okay. Yeah, go ahead. Grab a mic if you've got one here.
Hi, I just have a question about the scalability for this Duncan upgrade. So do you think this will help on the improve the TPS, like transaction per second for the L1, like Ethereum, or and the on the L2, or if it does, like how it help solve the scalability issue?
It doesn't improve scalability on L1. And on L2, what it does is it gives you cheaper access for the same scale. So like the amount of TPS doesn't necessarily go up, but the price for those goes up. And L2s aren't necessarily bottlenecked on like, they're not like at full execution right now. So like L2s can do a bunch of stuff to improve their own scalability, which is like sequencer bound or just like data compression bound. But like on L1, this doesn't change much, but think of it as like for a given level of scale, this makes things cheaper rather than like it increases the total possible scale. Does that make sense? Yeah.
Cool. You wrote earlier on here. You kind of referred to like going from proto dank sharding to like full dank sharding. And that's kind of, I'm guessing, one of the next iterations of it. Is there other things that this unlocks, and like what other kind of next things does this lead to here for Ethereum?
Yeah. So this is like the big one, and the thing that's very neat is from like the user perspective, like the sequencer or whatnot, going from like this to full dank sharding literally just looks like adding more blobs. So like if you're like Optimism, you don't need to do anything between now and full length sharding. It's like there's these blob transactions. Right now there's 3 per block. Maybe we'll increase them to 6 per block. And then maybe when we have full length sharding, it's like there's 15 per block or something. And you sort of, you just keep sending blob transactions and that's it. So that's really nice. Like this upgrade, like we really focus on just getting all the like front end, for lack of a better word, like all the infrastructure for like sequencers and whatnot. And hopefully if we did that right, then this should not change. And then we can just like in the background keep scaling and like, yeah, have more capacity for blobs.
Okay, sweet. I guess one final thing, or yeah, go ahead.
I think the role that you play in actually facilitating these design and engineering meetings is really fascinating, probably hard. I'm curious, were there particular design decisions that were hotly contested among the engineers? And if you could share a little bit about how you guys reached some consensus and direction for those choices.
Yeah, man, all the hard ones. So I work mostly on the execution layer on the EVM stuff. And the blobs are mostly not on the EVM. So probably the one we like went back and forth the most on is like when you sync, should the blobs be sent with the blocks or separate? And we like debated this a ton in January 2023, made a decision, and then literally reversed it like this fall after just a bunch of testing. I think I don't know that there's like a great way to go about this more than like first like just trying to get to the root of the disagreement. This is probably like the worst way to waste time is like when we have people arguing about something and like there's a more fundamental disagreement. So if we can actually be arguing about like the main core thing, that's good. Even if like sometimes we get it wrong, like in this case, you just fix it. And like I don't know that there's like a better way, to like do that. Someone I work with says, you just have to care more. But it's like hard to, you can't like force that. And I think like, yeah, making sure like finding the right balance between like making space for everybody to like come in and like share their perspectives, but then also moving forward. Like, I think this is probably the hardest thing where we can't be like as efficient as like a company are. And when I work with like super productive people and they come to work on Ethereum, they're like insanely frustrated at how slow things are. But like the flip side is we actually, are an open project and we have it's like 160 people who like contribute to core protocol development, at least. So like there's not a lot of other like companies that like manage a single code base in the open with that. So I think it's like, yeah, finding the right balance between you sort of hear everybody out, but at some point you sort of have to make a call. You hope it was the right one. And then when it wasn't, you try to think about like, okay, what happened and what could we've done better? And probably the thing we've gotten like the best at in the past couple of years is just building better testing infrastructure, which lets us just like try out stuff super quickly in like a lower stakes environment. And yeah, like, figure out if we did the right thing, then great, we move to the next. And if not, we just fix it. Yeah, no silver bullet. Sorry.
Yeah, I'm curious. Do you know which L2s are prepped for blobs right out of the gate, and maybe more interestingly, which aren't?
Pretty much all of them that I've spoken to are. We've deployed this on like 2 or 3 testnets actually now already. So like all the ones I've spoken to, ZK Sync, Arbitrum, Optimism, Starkware, I forget some other ones too, Metis, like they all told me they're pretty much going to be ready for mainnet around the time they ship. Some might be like a week or so after because they just want to like see it live. But like, I don't think there's a major L2 that's going to be like 2 months without blobs or something like that. Yeah.
Partly a question from Restream, but then also kind of follow up. Question from Restream is it a hard fork? I think you've mentioned this, but yeah, it's a hard fork. And then for the test nets, do L2s have to migrate to a new test net?
Okay, yeah. So for test nets, we periodically shut down test nets on Ethereum because they just become like hard to maintain, and there's like no incentive for like validators to run a testnet. It's like you get paid testnet tokens and they're worth nothing, or like you have to mine, and like you're spending computation and you get nothing in return. And so as the testnets like grow super old, they become basically as expensive to run as like mainnet. So we tend to shut it down every couple of years and launch new ones. So we shut down Gordy. So we said we're going to shut it down 1 month after the fork goes live. So this would be April 15, give or take. So L2s that were using Gordy, but any application that was using Gordy sort of has to move on at that point. And then, yeah, so like we have these two other testnets now, Sepolia and Hosky. L2s have like pretty much mostly migrated there. And yeah, they can just keep using that as is. And both those have already forked and support the blobs.
Cool. So Sepolia is good for another couple.
Yeah, Sepolia is good for another couple years. Hosky even longer. Yeah.
Any other questions here? We'll kind of open it up to.
Hey there. I know we spent most of this talk about the pro-dank sharking, but there's other improvements. Can you do a quick overview and then the impacts of all the other fun things that are happening?
Yes, and I'll get out my phone to make sure I actually read the whole list because I did this the other day and I missed some. So let me actually go through them in order.
And is there any other questions from online that we're seeing from Restream?
Okay.
And if anybody that's listening is looking for answers, you can just hop over to Discord or does it work on X? If you ask on X, YouTube, whatever, just hammer it into the comments and we'll feed your answers. All right, go ahead, Tim.
Okay, I'll do like a 10-15 second description of each, and if people have questions, we can dive in. So EIP 1153 is introducing new opcodes tstore and tload, and they're basically storage that gets cleared at the end of a transaction, and so it's cheaper. It's almost like blobs for transactions. Again, butchering the explanation, but yeah, storage that clears at the end of a transaction. Other EIP 4788 exposes the beacon block root in the EVM. So right now, you can't actually really make proofs about the beacon chain on the execution chain without some sort of external oracle. So we have this EIP where every block, the beacon state root just gets shoved into a contract on L1. So if you're like a liquid staking pool or something and you want to make proofs about the state of the beacon chain without relying on an external oracle, that'll be live on chain. 4844, we just talked about it. EIP 5656, mcopy, memory copying instruction. I don't know enough about VMs, but like the EVM people that talk to me about that get super excited. So if you're writing EVM code, look at that. Probably the second most important one is 6780. So we have this opcode on Ethereum called self-destruct. And the idea is it basically deletes a contract from Ethereum. The problem with this opcode is that deleting a small contract doesn't take a lot of time. Deleting a huge contract takes a ton of time, and you sort of can't know in advance because all you're given is like an address. So it's one of these weird cases where you pay some amount of gas, but then you don't know in advance how much computation you're actually going to run. And for like years, we've wanted to delete this. And then we have another upgrade coming where we're changing how storage is like represented on Ethereum. That's even less compatible with this. So we're basically deactivating the self-destruct opcode. So it'll no longer be possible to delete a contract. If you've used self-destruct, you might know that it also sends your money to a specific address from that contract. So that functionality will still be there. There won't be any funds like bricked within like a specific contract anywhere. And then there's one exception as well, which is if you create a contract and delete it within the same transaction, it doesn't actually have to be written to disk, so you can still self-destruct that. And people do weird tricks to like burn some ether that way, where they just create a contract and then self-destruct it during the same transaction. So if you're like writing contracts and like you've used self-destruct or you interact with stuff that does, this is probably the EIP you should pay most attention to, because even though it won't break any contract, it just changes the semantics of like what the opcode actually does. So 6780. Okay, next one, 7044. So on the beacon chain, you can pre-sign an exit message for your validator. Up to now, it was only valid for like 2 hard forks after I don't know why they made that decision, but then we realized it's kind of a bad decision because imagine you want to like set up a staking pool and pre-sign an exit message that you give to your users so they can always exit. You don't want this to expire. So after this fork, the exit messages will be that are signed will be valid forever. Okay, this is getting super technical on the beacon chain, but 745 increases the max attestation inclusion slot. So like how far in the future can you include a valid attestation? There is a really good reason for this. I wrote an explainer about it like 6 months ago, and now I'm blanking on it. But if you read the EIP, they sort of tell you why this. But basically, you can just and if you're running your validator, it'll all happen automatically. But you can just include attestations from farther distance. Okay, and then this one's also interesting. 7514 adds the max epoch churn limit. So up to this fork, the number of validators that can be activated every block would go up as a function of the total number of validators. So it'd be like a percentage. So I think the number was like, I don't know, like it was around like 3 to 5 based on the number of validators, and it sort of grows as a function of that. And we realized like that's probably way too fast as more and more people start staking. And if we want to like potentially move to a world where not like where there's some sort of bounds on like how much each should be staked, we may not be able to do that if we just did nothing and let sort of the trend continue. So this basically limits how many new validators can be activated in a specific block. And then last EIP, very simple, blob-based fee opcode. So if you want to know how much blob costs, there's an opcode for that. And the reason for this is for L2s. Well, there's a bunch of fun stuff I guess you could do for this, but like the main reason is L2s can then have like some gas price oracle for the sequencer on chain directly. And so if you want to have things like, you know, user mass exits or whatnot that like just use the chain, or just like bounties to submit fraud proofs or whatever and reimburse people's gas costs, yeah, you can use that. We have the exact same opcode called base fee for like the gas base fee, so we added one too as well. So that's everything that's coming in the fork.
Yeah, thanks, Tim. So just kind of hearing, thanks for the overview. It sounds like this Dankun upgrade is like helping developers, some for stakers, some for general ecosystem.
Yes.
I'm just kind of curious, what's kind of the motivation? You kind of talk about like the motivation that kind of drives, you know, improvements to the Ethereum protocol. Maybe trivially as a user, you might be like, transaction price should go down, but that's clearly not the kind of focus that you guys have. So what kind of motivates these EIPs?
Well, to be fair, I mean, 444 is about the price of L2 transactions going down, right? Like,
maybe just L1s.
yeah, I think, okay, this is like a poor analogy, but it's the best I've come up with. The way we think about hard forks, I think like the closest thing you can think of is imagine you're organizing a music festival and you have like 1 or 2 headliners and then a bunch of support bands. There are like these bigger things that just like take a lot of time and end up being your focus. And there's not really a great rule to select them, except like stuff that's really important, that's at the spot where like the research is far enough that we can actually work on it. And usually there's not like 10 of these at the same time. Like, I don't think it's ever happened that we had like 2 things of the size of 4844 or the merge like ready at the same time to like be like worked on and become the main feature. But that's basically what we build the fork around, because it's like if you're doing 4844 and say you have like, I don't know, like this mcopy EVM opcode, like you're not gonna like remove 4844 from the fork just to do mcopy because there's so much code complexity. Whereas like if for whatever reason like there's a bug in mcopy that we missed, we'll just like nuke it and like ship the fork without it. So like in terms of just project management, we have to like make a call on like what is gonna be like the big important thing, and then, you know, focus on that. And after that, just try and do like as much other useful stuff as we can. Stuff that's like unrelated to each other is great. So like 4844, you know, has all these blobs on the networking layer. So like we don't really want to do a ton of other stuff that touches like, you know, gossip on the beacon chain. But sure, you know, we can add a bunch of opcodes to the EVM and it's like completely separate. There's no like interference in terms of testing. So that's like the main concern. And I'd say in terms of like L1 scaling, realistically, like the only way to scale L1 is through stateless clients. So the biggest challenge with like why you can't scale L1 is the state of the network. So the state is like everybody's balances, all the contracts, all the code in the contracts, all the storage in the contracts, everybody's like ERC20s and whatnot. As that grows, it's like it's not even like the history of the chain, right? Like you can discard the history and just like make proofs about it and whatnot, but like the state, like this is like my balance today. This is like the most important thing. Today, there's not really a way on Ethereum to like only have part of the state with you. Like you have to download the whole thing. It's already a couple hundred gigs. So if we like 10x the gas limit, then it would be like a couple terabytes in the next year. And then you'd like take out all the nodes on the network. So that's like our number one constraint. Paradigm just wrote a really good article on their blog looking at like what actually makes up the state, what's like the rate of growth of different things. So like if you care about that, I'd really recommend that blog post. So the biggest challenge to scaling is the state size. The biggest challenge to the state size is like you could just send proofs of the state around, but today these proofs are way too big. And again, poor analogies, but like the way we store data today on Ethereum looks a bit like a Christmas tree. So it's like this long and skinny tree. And if you want to send a proof of like your balance, you have to go from the top all the way to the bottom and send like that whole branch. So it's like a vertical branch. But anyways, and those are just too big to gossip. So our goal is to move to a tree that looks a bit more like a bush, which is like super long and narrow. And then once we have that, we can send all these small proofs. So this is actually the focus that like we'll be working on in the next couple years on the execution layer. While they do like the full danksharding, we'll be working on like the tree conversion. And removing self-destruct was actually one of the blockers for that. So it's like it sets the stage for that because, and now we're getting really technical, but like with the Christmas tree, self-destruct is not too bad because you can just, it's all like a common root. But with the bush, like the data is actually spread around the tree. So like self-destruct would force you to do like a full scan of the entire state, and that would just not be possible. So anyways, long way of saying like for the big things in the fork, we're sort of bound by just R&D speed. We do care about L1 fees. I don't see another way aside from stateless. Once we have stateless, then yeah, we can raise the gas limit because you can only store like whatever you care about it. But it's still a couple years away. In the meantime, we have blobs on L2.
Thank you.
Yeah, of course.
Are those the next headliners that you would go for? Any others?
Yeah. So we've already decided. So actually, this is the other thing as well. It's like we're like alternating between like big forks and small forks now, which feels right. So we shipped the merge. Fork after that was withdrawals, which was like a relatively small fork, and now we're shipping the blobs, which is a big fork. And after that, we have another small fork, which we're still sort of debating. We have a couple things that we've agreed to, but like still debating the full scope. And then we're also working on this vertical trees in parallel, and then on full danksharding on the consensus layer side. So and what's nice is just you can kind of parallelize this, like. You know that full danksharding is going to take a couple years. You know that like vertical trees is going to take a couple years, but like we can still probably do like a relatively small valuable fork in the next year or so. So we have like the two big headliners, it seems, for like not the fork after the one after that, and we're like debating small stuff to include in the meantime.
Hey, microphone.
What, do you foresee any of these being contested the way
Like the big
proof of stake was and
like the big items?
big EIPs, yeah.
I mean, I don't know. Like it's probably so. Okay, so on the full danksharding side, the biggest like argument that you can see is just like it requires more bandwidth by validators, and there's a couple other proposals to like reduce that, like just consolidating validators. So that's probably the biggest one. Like if you felt like it's not worth it to like have this increase in data throughput, if it means like less validators or less like home operators. Aside from that, like maybe like the other thing as well is like you could say like, you know, you don't trust like this probabilistic guarantee, but honestly, if you're using Ethereum today, like you're making a lot of probabilistic assumptions, you know, throughout the stack. I think for vertical trees, like you could argue like it's maybe not like the best type of tree and whatnot, and like that's fine. I don't have like a super strong opinion there. I think it's decent. The biggest challenge for vertical trees is more like how we transition, The first proposals were like, we're going to just shut down the chain for a week and do the transition, and then that obviously, did not happen. But like that's but that's clearly something where like like sure you guys want a new tree, and it would probably save like 6 to 12 months of engineering to just shut down the chain for a week and do that. So it's like no, you just bite the bullet and like work on it longer and don't shut down the chain. But yeah, I don't know. They feel like more like background maintenance, technical upgrades than like the merge was, which is like
No more new fork shit coins.
I don't know. Yeah.
Other questions? Here we go.
To enter the validator pool, you said there's going to be they're going to limit or slow it down. What about exiting? Would that go with that as well?
No, we're not changing the exit. We're not. Yeah. I personally would have like made them the same. Just it's like nice aesthetically, but there actually isn't like as strong of a reason to change the exit. So we haven't done that.
But that's just going to blast the wait list up essentially, right? I mean, it's not going to change overall the amount of people eventually coming in. It's just going to increase the wait.
Correct. And I mean, well, you can see like the increase in wait time as like some disincentive. Like imagine it takes you 2 months to like come in. It's just a random number. Then when you think about your yearly reward, it's like you have to take that into account.
Right. Okay. Thanks.
Other questions? Anything else? Oh, go ahead.
Yeah, so you just mentioned like we cannot scale the L1 using this one, and we are relying I think on Proto Shandak fully like shank approach like fully sharding to solve the scalability issue, which takes like maybe 5 years or even more than that. So right now we rely on the L2 to solve the scalability issue. So do you have any like right now I just see the L2Bs like it says like maybe 30 transaction per second for most of the highest throughput for the L2s. So that doesn't seem solve this issue. Is this because there's not much user activity?
Yeah, L2s right now are not bottlenecked by like the amount of transactions their sequencers can jam in a block. They're mostly bottlenecked by fees, like how many people will pay $2 for a swap on Optimism. More like the actual Optimism sequencer can like include more of those transactions. Yeah. So maybe another way to say this is like the block space on L2 is not full right now. Yeah.
How much can you? So some L2 claims like they can handle maybe like tens of thousands transactions per second. But what do you think? Like, do you think it's like reliable?
Yeah, like I mean, look, when I see an L2 doing tens of thousands of transactions per second, then we'll have it. I think it's easy to like abstract away the engineering details. I do think like ZK rollups like do have a claim to that, where like there are efficient compression techniques and where you can build like optimistic rollups sort of have this problem where like the more and more transactions, the more and more data. ZK rollups have more of like it's not quite like a fixed amount. And I mean, you might be able to tell us more, but they have more of like a fixed amount of computation to generate the proof regardless of the amount of data, and they're bottlenecked by other things. So like, yeah, I think we'll keep seeing the throughput improve. I mean, people are working on say like parallelizing EVM computation as well for L2. So I think it'll be like pretty exciting. Like I've there's even some teams building like Solana virtual machine L2s on Ethereum because they think that like that virtual machine is just more optimized, but then they want to settle on Ethereum. So I think like we'll see a bunch of different approaches try to scale. And some of those will like get users and get adopted. But I think like it doesn't feel to me like we're anywhere near like the max. Like it feels like we're still like many orders of magnitude away from like what L2s can actually do with like better engineering and better proof systems. Yeah.
How long do you think it would take for like L2 like to reach maybe like for real use cases like for a kilo for a kilo app to show up in the Ethereum network, either L1 or L2? Like how long does it take for the L2 to handle this kind of real use cases like maybe without TPS, like maybe tens of thousands? How long does it take?
I think we just keep moving the goalpost on that. Like I remember like in 2018 I would look at like the top 5 users on Ethereum and Gaswise, and they were all scams. Like not like a project I don't like. They were like literal Ponzi schemes. And today they're all, I don't know, it's like Uniswap and like OpenSea or like actually like real products. So like I mean, I don't know. Like we have like I use Farcaster all the time. I have more Farcaster followers than Twitter now. Like I use it as often. I feel like we have real products. And like also like maybe you don't have to put everything on chain. Like I'm super bearish when people are like, I don't know, we're gonna build a game and record like every single like command thing on chain. Like why? You know, you don't need to put that on a blockchain. So and then oh yeah, and then people talk about this is I guess like what people talk about like L3s and whatnot. It's like maybe you have like this small ephemeral chain that's like recording stuff, but then most of that stuff's not really important, but the outcome of it is, and you just aggregate that. So yeah, I don't think we're like we're as bottlenecked by like transactions and whatnot as people like to say. I think we have decent apps and like we'll keep seeing more.
All right, we're getting close to the hour here. Maybe a couple last questions, or we'll start wrapping things up. Anything else? Oh.
Yeah. So I heard you have an opinion like over we don't want to put everything on chain, but like I saw lots of like fully on chain game. I'm just curious what you think about those games or other application utilities that people try to put more things on chain.
I'm like pretty agnostic. Like you know, like the chain charges you a price to like put stuff on it, and if you find users willing to pay that amount, then that's great. You know, I used Farcaster as an example earlier. Farcaster doesn't put everything on chain, but it uses an ETH address to sign in. There was a Twitter clone like in 2018 or something that did put every single like blockchain tweet on chain, and it just like never got users because it was just a bad thing. And it turns out like you don't really need that. Like the thing I want on chain for Farcaster is like my username mapping to my address, and like from that people can then derive and retrieve the tweets. So I think it's more about like being smart about your architecture. And you are seeing like more and more of that. Like you know, Dark Forest was another like really interesting game. Just figuring out like the right balance of like what information do you put on chain, what do you let people like extrapolate from there. Yeah, so I'm not smart enough to build those things, but just like when you look in practice, it seems like yeah, people come up with like really interesting like architectures that still work.
Thank you. And I'm also just curious about dank sharding in general. Like overheard there was 6 blobs. So is there any plan like in the future, like the ultimate solution for that will be more blobs, and does it look like?
Yeah. So basically more blobs. And so what we can do is we can raise the number of blobs after this fork if we want to, but then you're just imposing more storage costs on validators. So there's a trade-off there. And the idea with full dank sharding is like we have more blobs, but the amount each validator stores stays constant. And then you become more bottlenecked by bandwidth. Like, you know, if say you have only 1% of the blobs, it means you need to ask the network about the other 99% and you know, make a bunch of calls and use like internet bandwidth for that. So like that becomes the other like limiting factor. Yeah.
Those blob sizes increase as well, right? Or do they stay at 128 kilobytes? I thought
I haven't checked, but
okay.
And this is like at the limit of my knowledge, but I thought that the KZG commitment that we use is like set to the length of the blobs, but I could be wrong.
Okay.
The fully on-chain game will be Blob Wars.
Nice. Okay. Anyone else? Any final questions here? I think that's.
Do blobs come with hats?
Oh, nice.
No comment.
Okay, awesome. Well, it's been great, Tim. Thank you very much for all the insight here. On all
thanks
this.
for having me. It's been fun.
Yeah. If people want to find out more about Denkun or anything, any resources you want to point them towards or anything like that.
Yeah. For hard forks, blog.ethereum.org. You can even sign up for emails. I will send you an email saying there's a new blog post about a hard fork. So there, and then I tweet about this stuff, and so I'm Tim Beiko on Twitter, and then Tim on Farcaster.
Can you spell that out?
Beiko.
Timbeiko.
Yeah, Timbeiko. And then Farcaster is easier, just Tim. So.
You have Tim on.
Yes.
Oh,
yes.
Damn, nice. Okay, so those are the two places to find you, and I don't know anything else you want to plug
No.
or anything else? Perfect.
Great, thanks.
Okay, wonderful. Thanks, everybody. Again, if you haven't already, please
Grab the
mint your
Pope.
Poe app. Do not fade that, please and thank you. Yeah, and I guess just if you don't mind, fold up your chairs and we'll stick them off to the side. And yeah, feel free to hang out for a little bit. But thanks everybody for coming out, and thanks everybody at that was listening at home. Okay, see you.
Thank you for answering my question.